All right, folks, welcome back. This is the PM session for Workshop 1. I'm going to start you with my slides that are actually WeBWorK problems themselves. So we're going to be looking at the slides through WeBWorK. It's a homework set, and it's titled here Workshop 1 PM PGML. So I'm going to look at this as though it's a problem set. There's some information at the right-hand side in the info section about some important problems that are there. And in particular, at the bottom are links to some of the documentation about the PGML language. I'll let you peruse those. We'll look at those more thoroughly next week, I think it is. But for now, I'm going to start at the first problem. Creating problems with PGML. As Gavin went over this morning, there are a number of components that a WeBWorK problem has to be able to perform, and that's setting up the values needed for the problem, creating the text of the problem, specifying the answers and how they're to be checked, and a solution to the problem, which is technically optional, but we encourage everyone to provide them. The problems are much better if you have a solution. There are two approaches to setting up problems in WeBWorK. Two styles of writing, and both of them do all of these things. The setup section is the same between the two approaches, but how they present the text of the problem is different between the two. So the traditional approach, which is not the one we're taking today, the text is entered between lines that start with begin text and one that starts with end text. And in between there is the text of the problem. Gavin showed you an example of a problem that was written in this format, and virtually all of the problems in the WeBWorK library are written this way. And then the answers are placed after the begin text, end text using a macro called ants, which associates an answer checker with an answer blank. And one of the problems with this approach is that the answers are very far away from where the answer blanks are, and you have to associate them yourself as you read the problem. And what goes between the begin text and end text can be complicated. So a more modern approach is the one we're teaching you in this course, which is to use the PGML language, which is the PG markup language. PG is the language in which WeBWorK problems are created. And one of the advantages of PGML is that the answers are tied directly to the answer blanks. There are other advantages as well, as we'll see. So we're going to be teaching you the second one. You have to be aware of the first one as well because so many problems are written in that format. But I hope that you will like PGML well enough to use it. All right, so benefits of PGML. One of them is that the layout is easier to control. Things like creating bold and italics and paragraphs and line breaks and numbered lists and bullet lists and headers and indentation and all that kind of stuff is more natural in PGML than it is in the traditional begin text, end text approach. Since you haven't done the begin text, end text approach, you don't know that, but when you look at some of the other problems later on that are written the other way, you'll be thankful that you've learned this one. Another thing that the traditional mechanism has trouble with is special characters that are meaningful in HTML, that is the layout that's being used for web pages, or the tech language that is used for the hard copy versions of your problems. The characters that are special in those languages are things you have to take special care of in the traditional approach. PGML takes care of that for you, so you don't have to worry about which output mode it's going to. Mathematical notation is available in several formats, as we'll describe a little bit later. We've mentioned this idea of what are called math objects. That's the topic of next Monday's presentation. So I'm only putting it here because it's one of the key things that really drove me to write PGML, was that it's difficult to control the output in the traditional format. So the output from math objects is straightforward here, very easy to deal with. And then the answer blanks are tied directly to the answers. So those are some of the benefits to this. The PG markup language was designed to make problem layout easier, and it's based on a language called Markdown. Some of you may be familiar with this. It's a language commonly used in blogs and other kinds of social media to allow you to specify formatting in a way that's easy and natural, particularly for people who were used to writing plain text emails and trying to make things that looked like bullet lists or looked like headers and so forth. It tries to use the kind of layout you would do if you didn't have anything but just your keyboard and the letters on the keyboard to indicate what the formatting would be. So it was a natural kind of thing where you didn't have to learn a whole lot of other language to do it. So it's easy to get headers, indentation, and so forth. But there's a link here to the actual Markdown language that this is modeled on. But in addition to the formatting, WeBWorK needs other features. So we add support for features like answer blanks and mathematical typesetting and variable substitution, the kinds of things that WeBWorK needs that a social media site doesn't. And these extensions to Markdown usually start with a square bracket and end with a closed square bracket. And almost all of them work that way to make them easy to recognize as the extensions. And the first character inside the square brackets determine the function of the extension. If you have used a Markdown before in some social media site, one thing to keep in mind is that Markdown has a lot of different flavors. That is, a lot of different implementations that have various extensions to it. So the things that you know from a Markdown you might be familiar with may not be available in PGML. Not everything is. So not every extension that you know about. For example, there's a table extension for creating tables. That's not in PGML. There is a link here at the very bottom to a PGML lab that I'll show you at the end that lets you interact with PGML you can type in little fragments of PGML and see what the results are like. We'll go over that at the end. All right, so how do you use this in your problems? Well, the first thing you have to do is load pgml.pl using load macros at the top of your file. You saw that earlier as Gavin in the examples from Gavin. And when you want text to be formatted by PGML, you put them between lines that start begin PGML and end PGML, as we did this morning. You can also create a PGML solution or a PGML hint in the natural ways. So you can put solutions and hints using this technique. So what are the ways of formatting material in PGML? So we're going to go through part of this today. We're going to go through this list today. There's more to it that we'll do next week, but this is enough to get you through most of what you need to do. So I'm just going to go through the formatting mechanisms here. So emphasis, things like bold and italics. To get bold text, you put asterisks around the bold. To get italics, you put underscores around it. So bold here, the word bold will end up in bold. Here the italics will end up in italics, and you can combine those to make bold italics. If I scroll down, this is actually the result of running this begin PGML and PGML block through PGML. So here we get a bold word that corresponds to the one there with the asterisks around it. We get an italic word for the one that had underscores around it. Then we get a bold italic word or bold italic phrase for the one that had both. Stars can be used inside a word, so inside gets the side in bold, but underscores don't. That's the way Markdown specified it. It's not my choice. And mostly that's because underscores get used within words in programming languages frequently to make a single identifier. And so they didn't want that to be turning into italics all over the place. I think that's the reasoning for it. So you can't put the italics inside that way. But bold and italics are easy to produce. Paragraphs. Paragraphs are separated by a blank line in PGML. This is one of the things that's easier than the traditional begin text, end text, where you had to put a variable named $PAR in where you wanted a paragraph break to occur. So this, you don't see any special markup for this, you just see a blank line. And if you run a line of text and come to an end of the line and continue on the next line, that becomes part of one long paragraph. And in the output, those two lines are combined. So the line break does not have a meaning, but a blank line separates paragraphs. For a line break in PGML, if you want to force a line break at a particular place, you end the line with two spaces. So you can't see it in this, but there are actually one space, two spaces at the end of that line that I've highlighted in blue. If you end a line with two spaces, that will force a line break at that location, even though ending could have easily fit up here, and ending a line probably could have fit up there. We forced the line break with the two spaces at the end here. You can do that even inside other markup. I haven't yet shown you that the hashtags give you a header, but if you end the header with, or end a line of the header with two blank lines, it will put a line break in the middle of the header. So two blanks at the end of the line forces that to be the line break. You want to avoid that kind of thing unless you really need it, because you don't know how big the person's screen is who's going to be looking at your problem. And if you're on a handheld, for example, you may force line breaks in really funny places if their lines have are short, for example, and it breaks someplace that you weren't expecting to break, and then you force a break someplace else. It may look funny. There was a question in the chat that says, so a hash isn't a comment inside PGML. That's correct. It is not a comment inside of this. That's because technically between begin PGML and end PGML, this is a string, a character string, along with line breaks and stuff in it, but a character string. And inside character strings, the characters like the hash mark don't have any special meaning in Perl, so it's not a Perl comment to do this. So in this case, we got the line breaks in those two places. All right, indenting in PGML is done by putting 4 spaces for a tab, but you aren't going to be able to generate a tab. But 4 spaces at the beginning of a line cause indentation. So this line will be indented. If I go down at the output, you'll see there's an indentation at the beginning of that line. And continues on to a second line. Since I don't have any spaces at the end of this line, these 2 lines get merged into one paragraph. So the fact that that I have a line break here doesn't matter. These become one long paragraph. But if I want to indent further, if I indented the original 4 spaces and then 4 more spaces, I get a second level of indentation in the output. If you want to go back to the first level of indentation, you go back to 4 lines. That works for everything except for going back to no spacing. Going back to no spacing, you only need to indent the first line of a paragraph. The rest will be indented to that same level, as you can see here. So in order to go back to no indenting, you actually have to end the paragraph. This is, again, how Markdown works. I didn't care for that too much, so I added an extension that says if you put 3 spaces at the end of a line, that'll actually end the indenting. So you can have an indenting ended without ending a paragraph. So that's a possibility too. But in general, if you're doing something in PGML, if you mark the first line of a paragraph, the rest of the paragraph will retain whatever that one is. So indenting is one of those examples. Centering. Centering in PGML uses these little angled, these little less than and greater than signs. Think of these as trying to push the text in these 2 directions from the edges. So this is pushing the text from both the left and the right, which pushes it into the center. Question has arrived. After periods, we put a period and a couple of spaces. One should not do it in PGML. You can do that. You shouldn't do this in HTML really at all, in things that are going to be in HTML, because you can end up having a space at the beginning of a line if you do that. If a line break occurs at the end of a line where you actually have two spaces, you don't do that. So you really oughtn't to be putting double spaces after a period in something that's going to be put into HTML anyway, because it causes trouble. And if you end a paragraph, if you are typing and you're doing this, as long as the double spaces are in the middle of the line, it doesn't matter. If you were to end a line that way and hit a return after those two spaces, that would force the line break. That was definitely true. So it's a habit that you probably don't want for PGML. Sometimes I would like space between text and the formula in a statement of a problem. That is actually not something you're going to be able to get very easily. So that's not an issue. That's an issue for another time. Let me think about what might be the best ways to do that. But spacing, again, in HTML and in tech are things that are not done by having additional space characters in the text. Those are done through other kind of commands. So it would be possible to force additional spaces, but I'll have to think of what the best way for that for you is. In tech, I use quad. There are special commands like that to do spacing, and one could do something like that in PGML, but there isn't anything built into it. You could use a variable to store things that would produce spaces, but it's a little bit outside the scope for today. And that kind of finicky spacing is frequently not something you want to do. Your idea of what the correct spacing is not necessarily going to translate into everybody else's environment. You really want to try to let the systems take care of the spacing as much as possible and not be finicky about trying to adjust that space, particularly if you're trying to adjust around a bug, because bugs are going to get fixed, and then your spacing is going to cause problems for the rest of the time your problem is in use. So don't try to work around problems, report the problems, okay, and get them to us and we'll fix the problems, and then you won't have wrong markup in the things you've authored that will cause you trouble in the future. So things like trying to space something around really specially, don't try to do that. Do the indenting, do the centering, that kind of stuff, but don't try to add extra spaces to get something to line up. Use a table or use something else that actually does the alignment correctly rather than fiddling around with spacing. That's just a good general habit. I understand the desire to try to make it look exactly the way you want, but it's not going to stay that way. As browsers change and as other kinds of output modes are needed, you're just going to get yourself into more hot water than you're saving yourself. All right, so centering again here is done with these little arrows from the two sides. So the first line produced this line that's centered. You can center several lines. These will be combined into a single paragraph that is centered. In this case, the paragraph is short enough to be all on one line. If you want to force a line break, you can do it. It's not these spaces here that are causing the line break, it's the one out here. It's those two spaces out there that force this line break. If I didn't have these two spaces and had all this space in front and around it, it would be perfectly centered as a single line like this, like the one here. Because the two spaces are after the less than signs at the right, that forces the line break at this point, right after that line. And again, you don't need to do every line independently. You can put the left one here and the right one at the end of the paragraph. So there's a lot of options about how you want to lay out your original text. Right justifying, again, you think about these little arrows as pushing the text. This pushes it all the way to the right. Several lines get combined. A whole paragraph can be right justified simply by right justifying the first line of it. And if you want two lines to be broken, you put the two spaces there. So here we got a line at the right. Several lines got combined. You only needed one thing for the two lines of source text, and this is the one that forced the two lines to be broken. So those things follow that pattern. Okay, so that's basic formatting. Next topic is mathematics. How do we display mathematics? And you were doing some of this morning without having known why you were doing it. Some people I know I talked to were confused by it. So this is why this is at least telling you what the things are. Not really why, but at least what they are. So mathematical expressions in PGML can be entered in two formats. You can use text notation, or you can use an algebra notation, which is the kind of thing that students type into their answers. Technically, under the hood, this is the math object parsed format, but I'm going to call it algebra notation for now. So if you want to do text notation, you enclose it in square brackets that have these little backticks inside it. That's for inline math, and you put double little backticks if you want display-styled math. So here is an inline formula, x plus 1 over x minus 1. Here's a display-style formula, x plus 1 over x minus 1. And this, you can see there's a difference between their layouts. Display style is allowed to take up more vertical space. Inline math is crushed vertically in order to try to prevent lines of a paragraph from being pushed apart. Note that there's a difference here between actual tech and PGML's idea here. Actual text display math gets put on a line by itself centered. It's not what's being done here. You get to decide how you want the math to be displayed, whether you want it to be left justified or right justified or centered, by using those commands we just talked about, indenting the little arrows to one side or another. So this does not produce a display equation. This produces an inline equation in display style, just like having the slash display style ahead. This works with LaTeX too. Well, this is LaTeX here, so yes. Note that, but my note at the bottom is there. I'm saying both of these are in line, but they're formatted differently. If you wanted to have a separate centered formula, you would put it on a separate paragraph with the indenting around, with the angles around it on both. Over is plain text. Oh, yeah, yes. Okay, so you're talking about LaTeX commands versus plain text commands. I consider them both text, so I'm not worrying a distinction for that. But yes, you can put LaTeX in there. Mathematics in the other format, the algebra notation, just like what students enter in their answers, is enclosed in square brackets that have colons inside, 1 for inline and 2 for display style. So here is that same fraction using the algebra notation. So this is like what a student would answer in their answer. And again, these are both inline formulas. They're just the spacing style is that of displayed equations in the second case. Algebra style notation is more sophisticated than you might think. It includes a lot of things like the ability to make sums and integrals and Greek letters and matrices and arrows and over and under braces and many other mathematical symbols. I'm not going to give you all of the details on those at this point. I'm just going to give you some examples that you can see that sophisticated math can be done even outside of tech through the algebra notation version of this. Now, of course, students don't get to write sums and integrals in their answers, but the algebra notation actually allows for those kinds of things. So here is an integral. The variable is x, and the integrand is 3x squared, and we're setting that equal to x cubed plus c, and you get that expression there. Alpha, beta, and gamma produce little alpha, beta, and gamma. Capital alpha, beta, and gamma produce capital alpha, beta, and gamma, and so forth. There is a lot of options in here in the algebra notation to allow you to do this. Later on, after next week, and we talk about math objects, it will make a little bit more sense what this is. But there's a special context, math object context called the typeset context that has all these things defined. There's a link here to a lab to let you play with this. And this lab is essentially all the documentation there is for this typeset context. There are examples here of how to do things like, a fraction. And if you typeset this, it will show you how it gets typeset. If you wanted to do something like a matrix, well, that's how you enter a matrix. If we type this, it'll get displayed like that. And these things give you examples of how to do this, like a compound matrix that produces a matrix of that kind. So there are a lot of examples here about how to do different kinds of things. These are for reference. These list all of the operators and functions and things that are defined. So if I use the word big circ, that will get me the big circle operator. So there it is. So these list all of the different things, different kinds of arrows you can get. So you could say things like x goes to 10. Well, this is an x goes to is this one, I guess. So x goes to 10. Looks like that. X maps to 10 would be this one, and so forth. There, I wanted to point this lab to you so that you could at least find it and use it as a test bed for what you might want to do. It's also listed on the problem list page. The labs down here, 37 and 38. These are the two labs that I've mentioned so far. All right, so that's sums and integrals. There are a couple of other pages of examples of these. I'm not going to go through them very carefully, but you can see there's a wide range of symbols that you can get. You can get accents. You can get other fonts. You can get different kinds of dots. You can get standard sets for natural numbers, integers, rationals. You can get over braces and underlines and things of that kind. And then you can get things like arrays with different kind of bracing. You can get cases. You can get vectors. The next thing you want to be able to do in WeBWorK problems is substitute values into the text. You saw that again this morning when we were looking at a problem about $A. So Gavin already talked about how you do this. You put square brackets around the variable name. And you can use not just a number, but a string, or when we get to it, math objects. This thing formula, or you saw compute earlier, these are ways of producing math objects that we will talk about in the next session on next week. But I put it here so the reference is there if you look for it later. So here we've got one variable that has a number, another variable that has a string, and another variable that's a math object. I want to tell you somewhat about the difference between these two as we look at the output for this. So the first line is, suppose we have A widgets, so we'll say 5 widgets will be the result. So there it is, suppose you have 5 widgets. This one says I want to put the value of my string into this algebra math mode. And since that string is an algebra text string, that should produce a fraction properly. This one says I'm going to take that string and stick it inside of tech notation. But that's not a tech fraction, so it'll output what tech would do for those set of characters. And so you get x plus 1 over x minus 1 correctly in the algebra setting, but you get this tech equation in the tech version. It's not displayed as a fraction. It's exactly the characters that you had in that string. And the difference between that and the math object version of this is that the math object can produce both a tech form and an algebra string, and it knows to do that in the proper setting. So when I insert a math object inside an algebra delimiters, it produces algebra notation, which produces the fraction properly. And if I use that math object inside tech notation, it generates tech form, which gets displayed properly. So the distinction here is you want to use math objects when you're dealing with these kind of things rather than a text string. Now, of course, you don't know math objects yet. I understand that. There's a chicken and an egg problem as we deal with these things all the time. What do we teach you about first? Well, in this case, we're teaching you about the text layout in general, and we'll get to the more fancy mathematical interactions later, but I want you to be aware that there is an easier way to get at the mathematical formulas from one form. You can get both of the mathematical outputs. So that's substituting. The last thing you need for WeBWorK problems is answer blanks. Answer blanks are easy. You just put underlines in between two square brackets where you want the answer ruled to be, and the number of underlines indicates how big to make the blank. So here is f of x in math mode equals an answer blank, and g of x in math mode equals a longer answer blank, and in the output you see exactly that. For this particular PGML problem, we didn't tell it what the answers were there, so you would have to use the traditional ANS call to assign answer checkers here, but we've seen already that there's an easier way to do it. And the easier way is to put the answer itself following the answer blank. So normally you would put an answer blank and say what answer you expect to go there inside curly braces directly following the answer blank. And if your answer is a formula like this, you simply put in quotation marks the formula you want. So this one says x plus 1 is the formula. This one is 3x squared minus 5. And this is the answer as you would expect a student to enter it. So this is algebra notation, not tech notation. So you would have used x plus 1 slash x minus 1 if you wanted to make a fraction. So this produces the same look, but now the answers are associated with it. And if I actually typed in an answer here, x plus 1, and a wrong answer, 2 minus 3x, and check these, you'll get that one is correct and the other is not correct. Okay? So this collapses together the two parts of a traditional problem where you have the text and then the collection of answers separately that puts them together. I think that makes it a little bit easier to tell what's going on, and putting the answers where you want them makes it easy to see where they are. There are a bunch of ways of dealing with the answers. You can store your answers as variables instead of putting them in directly. This is particularly helpful if you have a long answer which would disrupt the flow of your text in the begin PGML and PGML. So here we've got four different answer blanks. I've got three variables. F has a string, that's 1 minus x squared. G is a math object formula for 1 minus x squared, and the variables a and b are 1 and 2. So I could say f of x is, and I could insert into these square brackets the value of f. Notice I'm not putting quotes around it this time. This is a variable reference. And so that's like having put, quote, 1 minus x squared in that location. I can put a math object formula in there as well, and that'll also be as though we had done 1 minus x squared. Or I could put a quoted string, and I could put even variable substitutions into that. 1 minus x squared in this case because b is 2 and a is 1. That would work. And if you have a numeric answer, you can just put a, or in this case, a plus b. So this says a plus b is a plus b, and that would compute the answer 3 and put that in that location. So the kinds of things that we were doing earlier about $AP1 as being a plus 1 is not strictly necessary. So you could have put $a plus 1 here, and it'll give you the correct answer. So I can put 3 here and 1 minus x squared into all of these other ones and get them marked correctly. So those are all the correct answers.